An ice age is a long period of reduction in the temperature of Earth's surface and atmosphere, resulting in the presence or expansion of continental and polar ice sheets and alpine glaciers. Earth is currently in a quaternary glaciation. Individual pulses of cold climate within an ice age are termed glacial periods, or alternatively, glacial, glaciations, glacial stages, stadials, states, or colloquially, ice ages. And intermittent warm periods within an ice age are called interglacial or interstadials. Today, we will be unlocking the secrets of the ice age. But before we commence, we would like you to take a moment and subscribe to our channel. Press the bell icon, and why not? Consider our Patreon. You can find the link to it in our description box below. So, without any further delay, let's get started. Although it is evident that there was an ice age, scientists run into a blank wall when they try to provide the cause. They run into mystery after mystery. But despite that didn't stop them to dig deeper into the cause of the ice age. Ice ages are a complex subject, but even with the complexity of this subject, there are three main types of evidence of ice age: geological, chemical, and paleontological. Number 1. Geographical evidence. Geographical evidence for ice ages come in various forms, including rock scouring and scratching, glacial moraines, drumlins, valley cutting, and the deposition of till or tillites and glacial erratics. Successive glaciations tend to distort and erase the geological evidence for earlier glaciations, making it difficult to date exactly. Early theories assumed that the glacials were short compared to the long interglacial. Number 2. Chemical evidence. The chemical evidence mainly consists of variations in the ratios of isotopes in fossils present in the sediments and sedimentary rocks and ocean sediment cores. For the most recent glacial periods, ice cores provide climate proxies, both from the ice itself and from atmospheric samples provided by included bubbles of air. Because water containing lighter isotopes has a lower heat of evaporation, its proportion decreases with warmer conditions. This allows the temperature record to be constructed. This evidence can be confounded, however, by other factors recorded by isotopes ratios. Number 3. Paleontological evidence. The paleontological evidence consists of changes in the geographical distribution of fossils. During a glacial period, cold-adapted organisms spread into lower latitudes, and organisms that prefer warmer conditions become extinct or retreat into lower latitudes. This evidence is also difficult to intercept because it requires, number 1, a sequence of sediments covering a long period of time over a wide range of latitudes and which are easily correlated. Number 2, ancient organisms which survive for several million years without change and whose temperature preference are easily diagnosed. And number 3, the findings of relevant fossils. Now, as we are reaching towards the end of the video, we would like you to comment down below of what you think about Ice Age. But not about the Ice Age franchise. Now back to the video. The Antarctic and Greenland ice sheets are still in place despite mild temperatures, indicating that the Earth is currently experiencing an ice age. When temperatures fall below freezing in some places, snow can no longer melt completely, and these global cooling spells start. When enough snow is accumulated, the bottom layer turns to ice and steadily advances, forming a glacier. As the sea levels fall at the same time, a cyclical pattern develops in which the snow and ice store the moisture of the Earth and feed the expansion of these ice sheets. Despite the difficulties, analysis of ice core and ocean sediment cores has provided a credible record of glacial and interglacial over the past few million years. Hence, the continental crust phenomena are accepted as good evidence of earlier ice ages when they are found in layers created much earlier than the time range for which ice cores and ocean sediment cores are available. There have been at least 5 major ice ages in Earth's history: the Huronian, Cryogenian, Andean-Saharan, Late Paleozoic, and the latest Quaternary Ice Age. Rocks from the earliest well-established ice age, called the Huronian, have been dated to around 2.4 to 2.1 billion years ago during the early Proterozoic era. The next well-documented ice age, and probably the most severe of the last billion years, occurred from 720 to 630 million years ago, the Cryogenian period, and may have produced a snowball Earth in which glacial ice sheets reached the equator, possibly being ended by the accumulation of greenhouse gases such as CO2 produced by volcanoes. The Andean Sahara occurred from 460 to 420 million years ago during the late Ordovician and the Silurian period. The evolution of land plants at the onset of the Devonian period caused a long-term increase in planetary oxygen levels and reduction of CO2 levels, which resulted in the late Paleozoic icehouse. Its former name, the Karoo Glaciation, was named after the glacial tills found in the Karoo region of South Africa. The Quaternary Glaciation, Quaternary Ice Age, started about 2.58 million years ago at the beginning of the Quaternary period, when the spread of ice sheets in the northern hemisphere began. Since then, the world has seen cycles of glaciation with ice sheets advancing and retreating on 40,000 and 100,000 year timescales called glacial periods, glacial or glacial advances, and interglacial periods, interglacial or glacial retreats. Earth is currently in an interglacial, and the last glacial period ended about 11,700 years ago. All that remains are the continental ice sheets and smaller glaciers, such as on Baffin Island. How does an ice age occur? The cause of ice ages are not fully understood for either the large-scale ice age periods or the smaller ebb and flow of glacial, interglacial periods within an ice age. The consensus is that several factors are important. Atmospheric composition, such as the concentrations of carbon dioxide and methane. The specific levels of previously mentioned gases are now able to be seen with the new ice core samples from Epica Dome C in Antarctica over the past 800,000 years. Changes in Earth's orbit around the Sun, known as the Milankovitch cycles, the motion of tectonic plates resulting in changes in the relative location and amount of continental and oceanic crust on Earth's surface, which affect wind and ocean currents, variations in solar output, the orbital dynamics of the Earth-Moon system, the impact of relatively large meteorites, and volcanism, including eruptions of supervolcanoes. Some of these factors influence each other. For example, changes in Earth's atmospheric composition, especially the concentrations of greenhouse gases, may alter the climate, while climate change itself can change the atmospheric composition, for example by changing the rate at which weathering removes CO2. Maureen Ramo, William Rudiman, and others proposed that the Tibetan and Colorado plateaus are immense CO2 scrubbers, with a capacity to remove enough CO2 from the global atmosphere to be a significant causal factor of the 40 million year Cenozoic cooling trend. They further claimed that approximately half of their uplift and CO2 scrubbing capacity occurred in the past 10 million years. The Earth's surface undergoes significant changes during an ice age. In their relentless push, glaciers transform the terrain by accumulating rocks and dirt and eroding slopes, their sheer weight pressing down on the Earth's crust. Cold weather plant life is pushed to southern latitudes as temperatures fall in places close to these ice cliffs. In the meantime, formerly buried land bridges between continents begin to emerge as a result of the massive decline in sea levels, which allows rivers to create vast interior lakes and deeper valleys. The glaciers create new lakes by filling basins with melting water when they retreat during warmer periods, leaving behind ridges of silt that are dispersed throughout the landscape. So that was all from today's video. We hope you would have liked this informative video till the very end. We mainly focused on keeping everything concise and easy to understand to reach a much larger audience and make it easy for them to understand. If you appreciate our efforts, then do make sure to give this video a thumbs up and share this video as much as possible with your family and friends. See you in the next video. Till then, take care.